Actually, we are quite proud of this site in the sense that it's not a typical example. First, it's completely inside the campus, but it's a walker's bridge inside the campus, and there is no other walkway for people to go through unless they really want to walk for 3 miles or something like that. So it's an essential part on the campus design, interconnecting two branches of the campus separated by a river stream. It's quite used in the sense that one of the campus canteen is actually on the other side of the bridge. So you can see how important it is for students which have their meals. There are lots of students' residence as well on the other side. So it's a quite heavily used bridge, all of wood, in a place with very aggressive elements, in the sense that it's in a very windy place because it's open to the water. We have lots of fog, lots of rain, so it's a challenging place for a trial. There were several phases here. We had some initial problems with lights, things like water getting inside. We had some other problems with the adjustment of the sensors and so on. There were several things that had to be adjusted, and they were only adjusted and fine-tuned on site, because it's not really the kind of work you can do on the lab. It's only on site. So I would say that after that phase, so going into the operational case, it should be around 5 months, roughly 5-6 months that we have the system operating. It's like comparing two different generations. You have the former way of looking at lighting, which in this place would be keep the lights on the whole night. And now what we have is an adaptive, intelligent approach to the lighting of the bridge. So we can retain a minimum level of lighting, while at the same time we can control the illumination level according to the student usages. For instance, it's very funny. I mean, a very peculiar result that we have that shows really the difference is the fact that when there is something like, a student party or something like that, the usage of the bridge during the night is much more intense. And we actually can notice that through a huge amount of variables. When you have lots of students passing across the bridge, for instance, the average temperature of the LEDs will be always higher, and you can see really the effect of having an adaptive system. Students are crossing the bridge the whole evening. You see the average temperature being high during the whole night. Students have a normal, working night, and what you really see is that after 1 o'clock the temperature slowly goes to the minimum value, because it's the minimum level of illumination that you have. So it's very interesting, gives us a very fine control of what kind of lighting power we put there, and even gives us a huge amount of information which we were not initially considering, but now we have real data about, for instance, the bridge usage. Of course, it is about energy efficiency, but from the moment that we start talking about energy efficiency in the sense of intelligent energy approaches, that requires us to take decisions based in some sort of information. And from the moment that we monitor and control that amount of information means that now we have a wealth of data that we have not before. And as long as you have data, then you can reason over it and figure out answers to questions that you were not even aware in the beginning that you could do and have answered. And at this moment, It is about energy efficiency, but it also is about the amount of data that we can extract, about usage patterns, about student habits, and some other actions, or in some cases some other reactions that university as a whole should take, considering this new feedback we have now. We have a challenge, which is there is an issue in the sense that we know that installation of such systems are more expensive, and that they do spend less energy. So the whole issue is the total cost of ownership. And the total cost of ownership, I would say that in many cases is still something that needs to be proved. And in that sense, these kind of demonstrators are essential to pave the way to global acceptance in public lighting of this strategy for illumination. Now, I do believe that as LED lighting will go, cheaper and cheaper, I do believe that it's a matter of time until the situation is handled in such a way that there is no doubt at all that the total cost of ownership is better. So I would say that in a 3-year time frame, we will still probably not see a so widespread distribution of such technology, but in a 15-year time frame we will. There is also a further problem that needs to be addressed, which is the regulations for public lighting. At this moment in many countries, those regulations are heavily constrained and dependent on, often on the major energy supplier, which means changing globally the type of lighting from the previous systems to LED systems requires some sort of acceptance from those energy distributors. This is a very complicated political problem, and most probably the European Union will need to provide some guidelines here, as it did for the home lighting conditions that we now have. I mean, now we are forced to move to energy-saving lighting. Probably the European Union should take a stand as well in public lighting, which it has not happened yet. Let me just take this time to acknowledge the amazing work done in the project for all partners, which in some very heavy water sailed during these years have managed to push the project forward and get a set of very nice demonstrators. I think the project as a whole has performed very well in the final outcomes, and we should strive to pass this message towards the European Union and the different communities in order that they can see the benefits that intelligent lighting systems can bring to their region, to their buildings, and of course to their energy bills.